Hi, welcome to my channel. Today we're going to continue in our color analysis series by implementing the previous script, get pixel HSV value into a new script, well, not a script, a new class. So we're going to have a class module, we're going to title it PixelConverter, and in this module we're going to go ahead and put all of that functionality from our get pixel HSV value within the class. And then we're going to add a little bit extra such that we can return our pixel values not just in the HSV color space, but in multiple different types of color spaces to have a real in-depth analysis. So you can see here we have GitHub. If you want to pull it from there, go ahead. But if you want to stick around, see things in detail, let's get into this. So here we are in PyCharm. We're going to go ahead. You can see the project structure up here, same as before. We have our get pixel HSV value, which contains an on mouse function, and then just a little script for opening a video capture and retrieving frames from our webcam, displaying them. And in this video stream, we go ahead and call that function to get our pixel values if we click on pixel. Now, we're not going to be changing anything in this, but instead, we're going to go ahead and in our PixelConverter module, we're going to find a class, and we're going to call it PixelConverter. States here that this class provides functionality to capture the pixels in an OpenCV video feed, and we're going to return them in various formats this time: BGR, RGB, hexadecimal, HSV, and RGBA. Now, we're going to do this in our on-mouse button or on-mouse method, but we first have to initialize our class. So let's think of the things in our previous script that we'd want to initialize our class with. Well, primarily the things that were just lines of code in that get pixel HSV value. And the first line of code was initializing our capture object. So we're going to take this in as a parameter of the class when we initialize it. And we're going to go and have it be default to 0 for our computer's internal webcam. And then we're going to go ahead and initialize the capture object as a part of our PixelConverter class. And we're going to go ahead and call the cv2.videoCapture on that video source 0 for our webcam. After that, there's not really much else we need to initialize that's from the previous module. I will note though, from the previous module, we didn't have to initialize this. It's part of a class now, and we want to be able to receive detailed information from it at different points throughout our program. So let's just say what this is. So we initialize the current pixel and the frame is none. So these aren't from our previous script because we didn't really have to get more detailed information from a pixel we clicked on other than its HSV value. So what we want to do in this one is get more values, BGR, etc. So we're going to go ahead and have this self.currentPixel equal to none when we initialize it, such that whenever we do run the program and we click on a pixel, our class maintains that pixel's state. And then we also are going to have the self.frame equals none, kind of for a similar reason. We want to hold that frame state so that we can really reference it within our class. We'll see this as we move on. Now, the last thing in our initialization is we got to create a list to hold the color space values for the current pixel. So in this on mouse method, we're going to go ahead and be performing a similar event check on our left mouse button. And then what we're going to do is with that left mouse button event, we're going to get the pixel's XY coordinates. And we're going to set that to this current pixel. And then past that, we're going to go ahead and do some conversions. And we want to be able to store these conversions so that we can print them all at once and not have to do a bunch of additional methods like get pixel HSV, get pixel BGR. And we don't want that. We would rather have one method that does it all. And we do this by keeping the states as a part of our class. And we keep it as the current pixel state, and then the current pixel info, which is attributes about that pixel, such as its different color space values. So let's see exactly in the on mouse how we do this. So we have the same doc string here. Don't worry about it. It's not any different from the previous module. We're going to continue as before. We're going to check if that event is equal to our left mouse button. If it is, we're going to continue and get the current pixel, except we're going to set that our class's current pixel equal to this. And we're going to set equal to this on the self.frame because we're not doing this in our video stream, but we're going to do this in a video stream method. So not a script method, a little different. Sorry if that's confusing. So once we get our self.current pixel, so that we have the current pixel equals that XY position of that pixel in our video stream, then we're going to go ahead and do some color conversions. We're going to do this by go ahead and our self.current pixel info, it's none when we initialize this and start running. But when that left mouse button occurs and we get the current pixel, we're going to go ahead and fill that list. We're going to populate it first with the current pixel, and it states here in the BGR format, default by OpenCV. This next line here, and let's say, so it's a list. So we have a comma here after the current pixel. So that's our BGR value. Then we're going to go ahead and convert that to RGB by reversing its order. We have to wrap this as a tuple. So that's our second item in the list, is our RGB value for that pixel. And then we have another line here after that comma. This is going to be our hexadecimal format for the pixel. So let's see here. We have this format specifier, the .02x. I have a comment here stating that this ensures that each channel is represented by 2 uppercase hex characters. So that's what this does. And then the dot format formats the current pixel as such. Now, so we have BGR, RGB, and hex values in that list. The next one we get is our HSV. This is from the previous module. We use the CVT color, and we go ahead and call it on the current pixel, converting it from BGR to HSV. Then lastly, one more value, we want RGBA, just to have full in-depth analysis. We do that by converting the current pixel to a list, and then appending a new value to it for that alpha channel. And we have to wrap this as a tuple because that's the type it needs to hold. So we got our current pixel at that position, and then we went ahead and populated our pixel info list with the different color model values for that pixel. That's what that all does. Finally, we're going to alter our print statement to simply print all of these pixel values in one line. So you can see that it might be a little confusing if you're not into Python code very deeply, but this is a print statement that operates with a join, and it's going to go ahead and loop through our color spaces and the values in that list, and it's going to print them in this format, BGR, RGB, hex, with the following pixel info. So that's really the key functionality we added and we implemented from our other one. Now this next one, get webcam pixels, very similar to our previous webcam stream methods. We're going to go ahead and start an infinite loop. I would note we could do this as while cap is open. That would maybe be a little bit more reliable way to do it. This works just fine. So infinite loop, where we grab frames read from our capture object, and then we show them, and then call our set mouse callback on that frame, which is the title of this window. And for the callback method, we're going to have to call our on mouse method, which will get all those pixel values, or the pixel value in all those formats. Finally, we have our wait key so that we can display the window, update it, or break out with the Q key. And that is it. Now we're going to go ahead and create an addendum main within this module. All it means by being a addendum main is that when we hit run up here and we're within this module, that this is the main loop that we're running. So within this main loop, when we hit run, we're going to go ahead and initialize the PixelConverter class. You don't have to initialize it with that webcam argument because it's going to be default to 0 for our internal webcam. And then after we initialize it, we're going to go ahead and just call that get webcam pixels to stream our video and call that on mouse method and get the pixel values. Let's test it. I'm going to go ahead and hit run and see the magic. Pull the window up here. All right. And I've got the balls, green, blue, and red. Should be a lot easier this time to correlate the different values we see with the different colors. So we'll start with red, we'll do it 3 times. You can see here, RGB 230, 208, 203. So 230 is the R value, or the R channel in our RGB color space. It can be max 255, so 230 is pretty close to 255. Now, if we keep clicking on the red, that changes. That's this lighting factor, right? It's a white light, so maybe in the certain color spaces we're going to get near white for the RGB, but that's why we're going to be using HSV when we take this into a more computer vision and machine vision approach. Let's go ahead and test blue and green and see here. So BGR, RGB, you can look through those if you want. It works. Let's go ahead and close out, see the full console output. We have all of our color formats that we specified in that method: BGR, RGB, hexadecimal, HSV, and RGBA. Now we have got a full depth color analysis of pixels we want to click on our video stream. And it's in a class, so it's going to be a lot easier to build upon this class and implement color detection. That's what the next video will be about. I really appreciate it if you come watch me with that one and hopefully learn something from it. But I hope you like this video. I hope you learned something from it. And if you like, comment, share, subscribe, anything you can do to help me out, I appreciate it. And until next time, have a great day.